Hi, this video is on effective rates. I wanted to show you an example of what this looks like, and then we'll talk about the formula. Okay, so you're shopping for savings accounts. You find one with a rate of 3.25% compounded monthly, and one with a rate of 3.15% compounded daily. Find the effective rates to determine which account has a better rate. So there's a trade-off here because the more we compound, the more money you get. But is it better to have compounding daily with a lower rate or compounding monthly with a higher rate? So that it can be really hard to tell. So fortunately, we have a formula for that, and it's called the effective rate. So let's go back up to the top of the page with the effective rate. Okay, so what the effective rate is it's the corresponding rate if we were to just compound yearly. So if we compound it yearly, then it's like we're taking each rate and we're putting it into yearly compounding so that we can compare them apples to apples. Essentially, that's what we're doing. Used to compare different compounding options. So it's called effect for effective rate. And what we put in is the nominal rate, which is the stated rate, and the number of periods per year. So it only has two inputs. And we have to do it once for each account. We get the effective rate, and then we can compare. Okay, so let's use this. Okay. So let's take the first one, 3.25% compounded monthly. So equals effect. Okay, and then if I'm not sure, since I've just covered up my formula, I'm going to go equals effect, and I can see it's a formula right there. Okay, so nominal rate and periods per year. So the nominal rate is the rate that's stated. I do need to change it to a decimal though, 0.0325. Monthly would be 12 periods per year. Okay, so we're going to get an answer for that. And then we're going to do the other one. Effective rate of 3.15% compounded daily, 0.0315. 365. Okay, do you have a prediction on which one is going to be better? I don't know. I think this interest rate might outweigh the more compounding, but I'm not sure. I think it's going to be close. Try to make one that would be close. Okay, oops, I did not want to cell reference in there. Oops. We'll talk about cell references later on. Okay, so effective rate 0.0325 comma 12, and that's all I have to do. Okay, so let's see what this means. 0.03, I'm going to do, I think, 4 decimal places so we can compare. 03298. Actually, I'm going to go 03299. And then this is where it's good to be able to see both numbers at the same time. So I'll do the other one, effect, and then I need 0.0315 comma 365. 0.0315, 365. It is less. So let me write this one down. 0.031999. Okay, so what this is saying is if we translated it, both accounts, into being compounded yearly, this is what the effective rate would be, the rate would be. So this one is, let's move the decimal over, it's pretty much 3.3%, isn't it? If we move it over 2 places, that 9 would bump that up to a 3. That 9 will bump that up to a 10, which bump that up to a 3. This one is move the decimal over 2 places, 3, 1. If we round anywhere out here, it's going to bump everything up and change that to a 2. So this is effectively 3.2%. Interesting, huh? So the higher interest rate generally does rule, but if these are closer, then the compounding might win out. This one, compounded monthly, will give you an effective rate of 3.3%. The compounded daily gives you an effective rate of 3.2%. So this one is better. The account with, find the effective rates to determine which account has a better rate. The account with 3.25%. Compounded monthly has a higher effective rate of 3.3%. Okay, so that effective rate formula is really useful. I've used it in real life actually with comparing 2 different youth IRAs for my son and trying to figure out which one is actually the better deal. So I hope that you will use it in your future. Okay, that's it for this video. I'll see you on the next one.